Just a century ago, our understanding of the cosmos was almost childlike. Astronomers believed that the Milky Way was the entire universe, that every star, every planet, and every spark of creation was contained within a single galactic island. The thought that there could be countless other galaxies, stretching beyond imagination, was beyond belief. Then, in 1928, came a moment that forever changed the story of science. A young astronomer, Edwin Hubble, through long nights of careful observation, discovered something extraordinary. The faint smudges in the night sky were not clouds of gas, they were entire galaxies, and they were moving away from us. The universe, it turned out, was not fixed. It was expanding, stretching outward, carried by some unknown force. That revelation transformed everything. Humanity's place in creation shifted from the center to the edge of something vast and alive. Decades later, the Hubble Space Telescope would continue that legacy, revealing that this expansion wasn't slowing down, it was accelerating. An invisible, mysterious energy seemed to be pushing space itself apart. Scientists called it dark energy, and it now makes up most of the universe. This discovery changed how we calculate the cosmos. It set the current estimate of the universe's age at 13.8 billion years. But today, that number is being questioned, challenged by the James Webb Space Telescope, whose eyes see farther back in time than any instrument before it. M92, the star cluster that defies time. One of the great puzzles of this new era lies in a glittering cluster known as M92, deep within our own galaxy. This ancient group of stars is among the oldest ever found, and according to new models, it may be as old as the universe itself, or even older. That shouldn't be possible. Stars are born after the Big Bang, not before it. Yet simulations involving tens of thousands of synthetic star populations show that M92's age pushes against the very edge of cosmic time. Could it be that our clock of the universe is wrong? Could the universe itself be older than the number we've always trusted? At the same time, Webb's deep field observations found something equally shocking: galaxies that existed only 300 million years after the Big Bang, yet already look mature, massive, and well-formed. By all known physics, galaxies like that should have taken billions of years to evolve. Something didn't add up. A new age of the universe. Some scientists now suggest a radical idea. What if the universe is not 13.8 billion years old, but closer to 26.7 billion years? If true, this would mean that everything we know about cosmic expansion, galaxy formation, and the history of matter must be rewritten. Perhaps our equations are incomplete. Perhaps the way we measure time itself, on the grandest scale, is flawed. The Methuselah star. The mystery deepens with one particular object, the Methuselah star, officially known as HD 140283. It appears to be 14.5 billion years old, nearly a billion years older than the universe according to standard models. That's not just an error, it's a paradox. Stars, by every law we know, can't exist before the universe itself. And yet, here it is, ancient, slow-burning, quietly contradicting everything we believe about stellar evolution. It's as if time moves differently for this star, as if it carries a memory of an earlier cosmos. The Hubble tension. At the heart of all these puzzles lies a single number: the Hubble constant, the measure of how fast the universe expands. But the problem is, we can't agree on what that number is. Measurements of the early universe, from the cosmic microwave background, give a rate of about 68 km per second per megaparsec. Observations of the modern universe, using nearby stars and galaxies, give a faster rate, closer to 73. That gap may seem small, but it's enormous in cosmological terms. This conflict, known as the Hubble tension, could mean one of two things. Either our data is wrong, or our understanding of the universe itself is incomplete. Some physicists believe the answer may lie in dark energy, that mysterious pressure pushing everything apart. Maybe it isn't constant at all. Maybe it changes with time, slowly altering the rate of expansion and reshaping our cosmic history. A cyclic cosmos, but what if the problem goes even deeper? What if the Big Bang wasn't a beginning, but just another moment in an endless pattern? The idea of a cyclic universe, one that expands, contracts, and is reborn, is ancient, but new evidence is giving it modern weight. In this view, each Big Bang is followed by a big crunch, and the cycle repeats endlessly. Perhaps the galaxies we see forming too early are the faint echoes of a previous universe, remnants of a time before our own. It's a bold idea, one that suggests the universe doesn't simply begin and end, but breathes like a living organism across eternity. The first architects, primordial black holes. There is also the question of primordial black holes, dense objects that may have formed moments after the Big Bang. If they existed, their gravity could have pulled together matter far earlier than we ever thought possible, helping to shape those mysterious early galaxies Webb now sees. But if that's true, then we must ask, what else hides in the ancient darkness before the first stars? What forces shape the structure of everything we see today? The multiverse possibility. Then comes the most daring idea of all, the multiverse. What if our universe is not unique, but one thread in a far greater cosmic fabric? If multiple universes exist, each with its own laws of physics, its own timeline, its own beginning and end, then perhaps they overlap. If these universes ever touch or interact, their energies could bleed through, creating anomalies in our observations, galaxies that seem too old, too big, or too bright. Could the James Webb Telescope be catching the faint reflections of other realities? Are we glimpsing beyond our own universe for the very first time? The quantum frontier. The mystery deepens even further at the smallest scales, the quantum realm, where time and space no longer behave like we expect. In the first moments after the Big Bang, quantum fluctuations may have warped space, twisted time, and seeded the birth of entire galaxies. In the depths near black holes, time itself stretches and slows. Perhaps in the very beginning, time didn't flow at all, perhaps it flickered, paused, and restarted in bursts, setting the rhythm of creation. Every image from the James Webb Telescope brings us closer to understanding, and yet, each discovery feels like a new question. It's as if the universe is daring us to look deeper. The cosmic revelation. So what if the universe isn't 13.8 billion years old? What if it's 26 billion, or even eternal, cycling endlessly through phases of birth, growth, and renewal? What if our universe is just one spark in a vast, multidimensional sea of existence? One thing is certain: the James Webb Space Telescope is more than just a scientific instrument. It's a time traveler, a storyteller, and perhaps humanity's greatest mirror, showing us not only what the universe is, but what we are within it. With every image it sends back, of distant galaxies, dying stars, and newborn worlds, it reminds us to question everything we know, to dream beyond our limits, and to keep reaching toward the unknown. So the question remains: are we standing at the edge of a new cosmic revolution? Or are we just beginning to remember what the universe has always known?